All right. Hello, students. This is Miss Medina, and this is your study guide for the Unit 3 exam. And so right now, I would like for you to have a piece of paper, pencil, a calculator. There's my calculator. Can I have my calculator here? Here it is. And no cell phone. Parents, if you're listening to this, no cell phones. They need to be paying attention. Thank you. All right, so number one, I need you to be able to tell if you have a function. So this comes from standard IF1. Right? So how do you know if you have a function? Is if every x is mapped to only one and only one y, and that's it. So here we have that -8 is mapped to 5, -6 is mapped to 4, -4 is mapped to 4, and -2 is mapped to 3. So every single x is being mapped to a single one. So there's no repetition. So is this a function? Yes, this one's a function. All right, and number 2, input is the x, output is the y. Clear? When x equals 0, it's mapping to 5. When x equals 3, mapping to 10. X equals 6, mapping to 5, x equals 9, mapping to 10. So even though the y's repeat, it doesn't matter. What we want is that every single x goes to 1 and only one y, and that is the case here. Okay. All right, number 3. So then yes, this is also a function. In number 3, let's look at the domain. The domain that we have is a 6, a -6, a +1, and a +1. Clear? This 6 is mapping to 1. I'm sorry, we don't repeat the domain, right? This -6 is mapping to -1. This 1 is mapping to 6. And this 1 is also mapping to -6. So right here, you can tell that they're mapping x equals 1 to two different y's. They're mapping it to y equals 6 and to y equals -6. So no, this one is not a function. All right, so why isn't this a function? Can you elaborate? Okay, good. All right, number 4. All right, the input, that means these are the x's. We have an x of 4, a 5, a 4, and a 7. Well, you see how this one, 4 is mapped to 30, and 4 is also mapped to 80. So 4 has a double mapping. So then no. All right, so double mapping means you're not a function. All right, number 5, for this, we would have to do the vertical line test. And so let me get the blue ruler. So as you can see, as we do the vertical line test, you're only touching the function once throughout. And so there's no, it only touches once every single vertical line, okay? So we're good. So yes, it's a function, vertical line test. Same thing with this one. See, through, only touches once. Only touches once. And so yes, this is a function. Now this one, I can already tell that it's not a function. You see, because this vertical line crosses the function here and it crosses the function there. So it fails the vertical line test, so it's not a function. All right, this one, all right, imaginary vertical lines. So as you can see, every single time we're only touching the function once. Okay? So then yes, this will be a function. All right, so looking at this, 4 maps to -3, 8 maps to -4. But right here, you see how 12 is mapping to -2, and 12 is also mapping to -1. This is double mapping, right? So no, this one is not a function. All right, 0 to 5, 1 to 6, 2 to 5, 3 to 7, 4 to 7. So yes, there's only one arrow leaving every single X, so there's no double mapping. Every X has only one pairing. So then this one is yes. All right, this is a graph. So then you use the vertical line test for this one, right? So as you can see, your vertical lines are only touching the graph once, the function once. Same thing here. Okay. So then yes and yes. All right, so look at the graphs in numbers 5 through 10. So these right here, which graphs have a maximum? So a maximum looks like this, right? It's increasing, turning point, decreasing. So there is no max here. Oop, this is a maximum right here. So number 6, right? That's a max. Let me see. Nope, no max here. Yep, this is a maximum right here. You see, through. So number 8. Let's see. So we're only looking at the graphs, okay? So then this one, nope, that's not a max, and this one, no. All right, so those are the only ones that have a maximum. Which ones have a minimum? And a minimum is going to look like this, right? You're decreasing and then you start increasing. So no, that's a maximum. This, no. All right, this right here is a minimum. See, it's decreasing and then increasing. Remember, we always read from left to right. Okay, so here it's going down, and then it starts going up. So number 9 has a minimum. Okay. And this one doesn't have a minimum. Okay. State the domain and range of the indicated problems. So for number 1, the domain and the range. So let's go back to number 1. Number 1 is here. Okay. And the domain is going to be all the X values. So let's see, -8, -6, -4, and -2. All right, so those are all the elements in the domain. The range is going to be, all right, so X values. The range is the Y values. Right? So they are 5, 4. 4 appears again, but we don't write it twice. We only write it once, and then 3. So these are the elements of the range. Okay. So -8, -6, -4, and -2. And the range is 5, 4, and 3. Okay. And they can come in any order. It really doesn't matter. All right, domain and range for number 2. This one's number 2. So the domain is the input values, which is 0, 3, 6, and 9. And the range is your output values, which is 5, 10, 5, and 10. But you see how the 5 repeats and the 10 repeats? We only write them once. There you go. All right. And then the domain and range for number 10. Ooh, which is a continuous function. So when we look at this graph right here, right, number 10, it's doing this. Now over here, it's going to forever approach the y-axis, right? But it's never going to cross it. So this is acting like an asymptote. And we mentioned this in class. It's also in the notes and in the videos, okay? It's going to forever approach it, but it'll never, the y value will forever approach the x-axis. And what is the y value of the x-axis? Y equals 0. Oh, wait a minute. I'm so sorry. I'm doing range instead of domain. All right, so the domain is when we try to put a boundary on the x-axis, right? But because the function rises forever, this boundary is going to get, further and further away. So we say that that's x infinity. Okay, that's how much room we need. And same thing here, the fact that this one's going all the way that way tells you that you need up to negative infinity. So the domain is negative infinity to positive infinity, also known as all reals, all real numbers. The range is going to be, okay, the first time we touch the function is right here. So the range is going to start here, right, at this y, and it's going to keep on going, right? Because we can draw horizontal lines forever, but because the function is going to grow forever, it won't stop. So we say to y equals infinity. So how do we say all the numbers bigger than 0? We say y is greater than 0. We say it can be from 0 to infinity. We say that it can be y is less than infinity, less than 0, so on and so forth. So there's different ways of writing the answer for that. Okay, number 11. Choose an answer from below, the domain. All right, so 0, 1, 2, 3, 4. So it looks, the fact that this has an arrow going this way, that means that we're going to keep on including x values. So the x values are also going to go on forever because the function is going to go on forever. So we say that starting from every single x value that is 0 and bigger, right? How do I know 0 is included? Because there's a dot right there. So from 0, bigger. So we would say, oh, and this is time. So we're going to use time. So time has to be greater than or equal to 0. So probably be that one. The range is the lowest y value. So if you do the horizontal line, the first time would be right here when y equals 3, or in this case, f of t equals 3. And the highest will be here at 12. Now, why doesn't it go higher forever? Because it's not going up, it's just going across the value of 12. So the range goes from 3 to 12, both numbers of which are included. Right, you can also do it like this, less than or equal to 12, equal to 3. Oh, I'm sorry, we're not using y, we're using f of t. Okay, f of t. Because that's what the y values are called, f of t. All right, domain. Now, the fact that this line is going forever that way means that x is going to go forever this way, right? So for the domain, it's negative infinity there, but then the function stops. It doesn't go on forever. So what is the x value when the function stops? 5. And it's included, right? It would get a bracket because the 5 is a closed circle. So the domain is from negative infinity until 5. Or we can say all the x values that are less than or equal to 5. The range is the lowest y values. So it starts at 3. And yes, it stops at 5 here. But you see how this one keeps on growing? So the y values are also going to keep on growing, right? So it's going to be every number from 3 and bigger. So y has to be greater than or equal to 3, or you can say from 3 to positive infinity. Okay, this one, domain. Domain is your x's. Now the function starts here. So the smallest x value is going to be -2. The highest x value, that arrow tells us that the function is going to go on forever. So the x values are also going to go on forever. So this is going to be infinity. Okay, so how do we write from -2 to positive infinity? Or you can say all x values that are greater than or equal to -2. All right, let's look at the range. For the range, the first time we touch the function is here at this point, and that's y equals 0. And so it might seem that it stops here, but this is slowly rising forever, okay? So eventually it'll be taller than this point, and it'll just keep going, keep going, keep going, slowly climbing. So it's going to go to positive infinity. So from 0 to positive infinity, or y is greater than or equal to 0. X-intercept is 3, right? So 3 comma 0. Y-intercept is 2, so 0 comma 2. Remember, for the x-intercept, the y is 0, and for the y-intercept, the x is 0. All right. F of x is graphed below. What is the range of the function? So I see the y-axis, x-axis, and it looks like this is open circles. That's at -2. So we're looking for range, and range is your y values. So we're going to be looking for horizontal lines. All right, and the lowest horizontal line is here, right? So it starts at -2, and the highest horizontal line is here. I'm going to make this one dashed because that's an open circle. Clear? So it's going to start from -2, and it's going to end at 1, but it's not included. Oh, they have this notation. So this will be f of x, right? Because it's y. Okay, so this is another way of writing y, f of x. Remember, f of x equals y. F of x is less than 1, greater than or equal to -2. So it's going to be this one. It's definitely not this one and not this one, because x refers to the domain. F of x refers to the y. Now they try to trick you by doing -3 and 3, right? But those are x values, and that's why this is not the answer. You have to look at the y values to do the range. Right, this one. This one's the steepest. So this one would have a slope of 6. This one is more shallow one, so this would be 1/2. And this one would probably be slope of 2. Which line is increasing at the fastest rate? Line 1, because it has a slope of 6. Oh, Lord. A farmer owns a horse that can continuously run an average of 8 miles per hour. This is the rate. for up to 6 hours. So it can only run up to 6 hours. Clear? No more. Let y be the distance the horse can travel. So y is the distance. X is the time in hours. The horse's progress can be modeled by a function. Which of the following describes a domain? All right, so the domain is x values, which means we are interested in x values. And they just told us right here that x is the amount of time in hours. And they told us over here that the horse can run for up to 6 hours, right? So the horse starts running at time equals 0 hours and stops running at time equals 6 hours. That's like the maximum it can do. All right, from here, from the choices, we can cancel A and C. Do you know why we can cancel them? Because they have an X right there. Oh my God, I made another mistake. I'm so glad I caught it. No, domain is X values, the ones that we can cancel. You can tell it's Friday afternoon, right? I'm sorry. The ones that we can cancel is this one, because those have Y's, and we don't want Y's, we want X values. Okay, yes, so those are the two that we want. And which ones have the right domain? This one. From 0 hours to 6 hours is what the horse can run. Okay? My apologies. I need to drink water. Okay, so look at 14. What is f of 1? Where is 14? Oh, right here. All right, so f of 1, that means that x equals 1. So if x equals 1, you're going to go to the x-axis, right? And you're going to go to 1. And the function is defined right here. So when x is 1, y is negative 1. So f of 1 equals negative 1. So this order period is 1 comma negative 1. Then it tells us to find f of negative 2. Once again, that is x equals negative 2. So we go to the x-axis at negative 2, negative 1, negative 2. And in fact, it touches the function right there. So the y value is 0, right? So this point is negative 2 comma 0. And so this one goes to negative 1, and this one goes to 0. The next one is, let's write the answers. This one's negative 1. This one's 0. Find x when f of x equals negative 2. All right, f of x equals negative 2. So basically, what is x when f of x equals positive 2, negative 2, negative 2? Okay, so this time we know y. We know that y equals negative 2. So we're not going to go to the x-axis. We're going to go to the y-axis. The y-axis is this one. And where is y equal to negative 2? Right here. Y is equal to negative 2, and what's the x value? The x value is 0. So x is going to be 0. When x is 0, the function is negative 2. When y is negative 2, x is 0. Okay. Solve the following. Using function g of x equals negative 4x plus 2 when x equals -5, what is g of x? So they gave us x. Since we know x, we're going to plug x into x. All right, so g of -5 is going to be equal to -4 times -5 plus 2. -4 times -5 is 20, and 20 plus 2 is 22. There you go. So when x equals -5, g of x is 22. So this is ordered pair -5, comma 22. Okay. Please make sure that you know how to do these problems. You should not be surprised when you see them on the test. All right. All right, number 19. Find the value of x. So right there we know that x is not known when f of x equals 10. And they tell us that f of x is equal to x plus 2. All right, we don't know x. The function equals 10. So that means this is 10 equals x plus 2. All right, subtracting 2 on both sides, x equals 8. So that's the answer on that one. Okay. Number 20. When x equals 3, so see now they're giving us x. So when they're giving us x, we're going to plug it into x, right? So we're looking for g of 3. And what was g of x again? Oh, right here. G of x is, I'm sorry, let me just copy the function. G of x equals -4x plus 2, right? And we want x to be 3, right? So g of 3 means -4 times 3 plus 2. What's -4 times 3? -12. All right, and plus 2, that makes it -10. Okay. So g of x is going to be -10, or basically g of 3 is equal to -10. So what does that mean? When your x value is 3, the output value is -10. This one says find x when f of x equals -20. So this means that we have to take the function for f of x and we have to set it equal to -20. And f of x is right here, x plus 2, right? So x plus 2 equals -20. All right, we subtract 2 on both sides. You get x equals -22. All right. Number 22. Given that g of x is the set of points below, so g of x is these points right here, right? This is how they're defining the function. Find this. I got this. All right, you see how the 10 is inside the parentheses? That means that x equals 10. So which of these points have an x value of 10? So it's going to be this one right here. See? When x is 10, the function is 0. This one says g of 6. The 6 is inside the parentheses, so that means that that is x equals 6. So now you go to the points. Which of these points has an x value of 6? This one. When x is 6, the function is 2. Now this one See the difference? You see how the 10 was inside the parentheses, the 6 inside the parentheses, but here we have an x inside of the parentheses. That means we don't know x, but we know the y value. We know that y is 0. Which of these points has a y value of 0? This y value is -4. This y value is 0. This y value is 2. And this y value is 10. So the correct answer is here. When the y value is 0, x is 10. All right, 23. What is the y-intercept? When you're looking for the y-intercept, you're going to focus on the y-axis. Clear? This axis right here, and then you need to figure out what this point is. And that point, since this is -2, this one has to be -1. So the y-intercept is -1. Y equals -1 or 0, -1.